So when you look at this equation, you have to know where it opens, what the vertex is. This stuff here, from here downwards, is information we often grade you on, not just your graph, but what you write in here. So when you look at a parabola, you can tell it's a parabola because only the x or the y is squared. And you look to see which one is squared. This one, the x is squared, so we know it's going to open up or down. Then you look for the coefficient. Now, it doesn't matter which side the coefficient is on. This is negative. I could move this coefficient to the other side by dividing both sides by -4. So on this side, it would look like -1/4. So it doesn't matter which side the coefficient is on. The fact that it's negative means that this is going to open either to the left or down. Because it's the x that was being squared, it's going to open down. So we know that this, what's in the inside the parentheses, gives me the shifts. This is shifted left 1, and this is shifted up 2. That gives me the position of my sort of reference point. On a parabola, that's the vertex. So my vertex is going to be at -1 + 2. Now, on a parabola, we then look for the focus. The focus is going to be down because it opens down. It's going to be underneath the vertex, so the x won't change, but it's going to go down by whatever our focal length is. Now, the equation tells us the focal width, which we call 4c. Its proper name is the lattice rectum, but at this school, we call it the focal width. The focal length is 1c, and you've got to be able to distinguish between those, whether we say focal length or focal width. It's very important, okay? Now, the focal width, you can read it in from the equation by looking at the coefficient, but you have to look at the equation because we can give these to you in many different forms, and you have to look at how it's set up. In the equation, are you seeing 4c itself, exactly what you need? Or are you seeing 1/4c? And it's not as simple as the fact that this isn't a fraction, so it must be 4c. That's not true at all, because if c was a fraction, then 4c itself would be a fraction. So don't just look at it and go, oh, it looks easy, so I've been given 4c. Or if you'd seen -1/4, think, oh, I must have been given 1/4c. It doesn't go like that. Look to see which side the coefficient is on. Is it on the side that is not being squared, or is it on the side that is being squared? If it's on the side that's being squared, that's more complicated. You've been given the more complicated form. If the coefficient is on the side that is not being squared, you've been given the nice, easy form. You've been given exactly what you need. Now, on the exit ticket today, you're going to do an exit ticket and you have to type it in, and I haven't actually fixed this yet. Some people would say that coefficient is -4, and they'd say 4c is -4. I tend to just look at the absolute value of it. I will try and hopefully I'll get time during the lesson to fix how it gets graded. But if you typed in -4 today for 4c at the moment, it would give you that wrong. But okay. So we've been given 4c equals 4. So c itself must be divided by 4 must be 1. So to get from my vertex to my focus, I'm going to go down by 1. And to get from the vertex to the directrix, I'm going to go in the opposite direction. I'm going to go up by 1. So there's a vertex. The focus is 1 down from it, and the directrix is 1 up from it. The focus is a point, so you type it in with parentheses and a comma. The directrix is not a point. The directrix is this horizontal line. And so you know it goes through the point that's 1 up from the vertex, but don't give me the coordinate of a point. Give me the equation of the line for the directrix. And you must tell me whether it's y = 3 or x = 3. You've got to get that right, okay? So any questions on this? Are we good to go? Let's move on. Now, this was your homework from yesterday. I'm going to pause the video for a second. So we need to actually practice some of these ones where you have to complete the square to get an equation in graphing form. So I'm going to do one with you, and then you're going to do one on your own. This one is too easy. I did that with my first period. Maybe I'll make a video of it, but it's too easy. We want something a bit more difficult. Let's do this one. So we're going to do this one together. Now, when you're actually writing an equation in standard form, we mean graphing form. This is given to you in what we call general form. We'll talk about that in more detail in another lesson. Now, we have not just parabolas. We're going to move on to ellipses and hyperbolas. And often we're going to be given an equation in general form like this, and we're going to have to turn it into graphing form. The technique is always the same, but it won't seem like it's the same when you get to an ellipse and a hyperbola. But listen carefully to what I'm saying about how to complete the square. Look along your equation. Look for anything that's being squared. In this equation, only x is being squared. So what we're going to do is we look for every single term that includes an x, so be this one and this one, and we're going to keep those on one side of the equal sign, and anything else that's to do with a variable that doesn't have a squared term, we're going to move to the other side. So that means on a parabola, we're going to split our x's and y's apart because only one of them will be squared on a parabola. When we get to an ellipse and a hyperbola, both variables will be squared, and we'll end up just moving things like the constant. So, but on this parabola though, anything that's being squared, our x's are being squared. So we're going to keep all terms with x's in on one side, and I'm going to have to move this and this to the other side. So I'm going to add y and subtract 5. That's going to be my first step. So let's write that out. Now, when I look at these are staying together on one side. Do I want that to be plus 3x squared or negative 3x squared? Well, I much prefer plus 3x squared, so I'm not going to move those. I'm going to move that and that to the other side. So I'll have y plus y minus 5 equals 3x squared minus 12x. And now I'm going to have to complete the square. At the moment, this is not ready to complete the square. I hope you remember from yesterday, you can only complete the square when there is no coefficient in front of your squared term. So the first thing I'm going to have to do here is I'm going to actually factor out that 3. This would make this become minus 4x. Now I'm going to be ready to complete the square. So I'm going to be adding in something on this side. And on this side, I've got the y minus 5. And I'm also going to have to add in whatever I add on the other side to this side as well. So now we're going to factor this side. So I'm going to write it as a perfect square. What was x squared is just going to become a plain x, because when I square it, it will become x squared. Now, do you remember what you do with this number here? You divide it in 2. Negative 4 divided by 2 gives me negative 2. So here I'm adding negative 2. But we never write it like that, do we? We write subtracting. So I'm doing negative 4 divided by 2 gives me negative 2. And what goes in here is that value I just wrote squared. Because you're squaring the negative, you're always going to be adding here. I'll be adding 4. Now, to keep the equation balanced with equals, whatever I added in on that side, I have to add to the other side. So what did I just add? I hope you didn't say 4, because I didn't. I didn't just add in 4. Look, this was inside parentheses, and I had 3 times 4. So I've actually just added 3 times 4 onto that side. I've added on 12. So on this side of the equation, I've got y minus 5 plus 12, which is y plus 7. And there we have it in graphing form. Let's actually move all this, split this down so we can see it. Okay, that's my equation in graphing form. What you will get used to on any of the conic sections, somewhere in your equation, you'll have x minus h, and somewhere else in your equation, you'll have y minus k, okay? You will see that in every single conic section where your hk is your reference point. And get used to the fact that you want, and you'd only have one x and one y, yeah? We have that, it's going to look better if I put that in parentheses. On this one, I'm not doing anything, but you'll just get used to seeing that as how we write the equation for most of the conic sections. So here's my, that goes with y, that one goes with x, that's giving me my hk point, which on the parabola is the vertex. So this is, what am I subtracting from x? Positive 2. What am I subtracting from y? Negative 7. I could graph that right away. Cross 2, down 7. Label it as your vertex. Now, to actually graph it, I need to know which way it opens, and I need to know what my focal width is. Once I've got the width at the focus, that's the lattice rectum, focal width, then I'll be able to find the focal length, which is 1c. So what have we been given here? What have we written? Here's my coefficient, but is my coefficient equal to 4c, or is my coefficient equal to 1 over 4c? You have to look and see where it is. Have we been given the complicated form, or have we been given the easy form? You've got to look. The easy form goes with, oh, I don't know if it's with something not squared. If you've got it next to the side that's squared, you've been given the complicated form. This is on the side that's squared. That 3 is not 4c. That 3 is 1 over 4c. And it's essential that you recognize that. So we know, if I want to make it the easy one, I'd have to divide it away to the other side. Now it's on the non-squared side, and now I know that 4c equals 1 over 3, okay? If 4c equals 1 over c, 4c equals 1 over 3, then I divide by 4, c would equal 1 over 12. My focal length is 1 over 12. Let's really fit that. Okay, another way to do this, we knew that 3 equals 1 over 4c. Cross multiply and divide. That would be 12c equals 1, so c equals, cancel out multiplication by dividing. Okay, don't just guess, do the math. So this one, how does it open? I'm looking at this now. So I look at my coefficient, and my coefficient is positive, and I look at what's being squared. Well, x is being squared. Oh, that's easy. It's a nice happy parabola. It's one of these ones. It's going to open up. So that tells me to go from the vertex to the focus. I'm going to go up by my focal length, which is c, which is 1/12. Oh, that's disgusting. So my focus is up just a tiny bit. So it's at -7 plus 1/12. Which would give me -6 and 11/12. Yuck. My axis of symmetry, oh, that's easy. Just look at what's the same in both of them. The x equals 2. Now the directrix, you get that from the vertex again. So from the vertex, if I went up by a 12 to get the focus, I'm going to go the other direction. I'm going to go down by my focal length, by c, down by 1/12. So from this point here, I'm going to go down the 12, but remember the directrix is a line. So I want the equation of that line. It's going to be y equals -7 and the 12th. Yeah, going down by another 12. So to draw this thing, the width of it, the focal width, so going through the focus, so where I've got this, where the focus is, that width is going to be 4c, which is, 4c was 1/3. So I'm going to go half to the left and half to the right. I'm going to go 6 to the left and 6 to the right. So it's really going to be this ridiculous parabola, tall and skinny like that. Now, if you're in KAP, they do loads of horrible, ugly parabolas like that with lots of fractions. We won't do many, but I'm glad that we got to see one in the class, okay? Let's try another one where you have to complete the square. At this point, do I have any questions from any of you? So now you try this one. I'm giving you 3 minutes, see how well you can do. You're completing the square, you don't need to graph it. Just complete the square, write me an equation in graphing form and recognize which way it opens. Go. So on this one, you could make it easier if you noticed this, but it's not important if you didn't, you'll still get the right answer. Did you notice that every single number could be divided by 3? If you didn't notice that, that's okay, you'd still get there, but every number could have been divided by 3. So you could write y squared plus 2y, and that's the only thing being squared. Now, I'll just write everything up here. Divide by 3 is minus 8x minus 15 equals 0. Now, it's y that's being squared, so I'm going to have y squared plus 2y on one side, and there's no x's being squared anywhere, so that's going to go to the other side. This is now ready to complete the square, so I'm going to put in the box for it. And I'm going to add 8x to both sides and add 15 to both sides. And I have to add in what I'm completing the square with. So now factor it. And so this is going to be y. And then I'm going to be adding half of this. So I'm adding 1 to both sides, and this time there was this wasn't being multiplied by something, so I am just adding 1. So on the other side, I've got 8x plus 16. Now remember, somewhere in our equation, we want y minus k. Somewhere in our equation, we want x minus h with no coefficient inside the parentheses with them. So this side's fine, that side's ready to go. But this side isn't. I can't have something in front of the x. I'm going to have to factor that out so that it becomes x, and it was positive, so it'll stay positive 2. Now I've got it in graphing form. It's got a positive coefficient. Y is being squared. This one is going to open to the right. Remember, if all I remember for that is y equals x squared means it opens up. If it's y being squared, it's going to open left or right. And if it's positive, it's going to open over the positive as opposed to the negative x-axis. So that's to the right. Okay, so that's how to do those ones. Right, there are more to practice, but there's something else we need to do in the lesson, so I'm not going to go over practicing that one. We're going to get plenty of practice on these in the next couple of weeks. It goes through the whole unit, having to complete squares like this. But there are other types of problems you can get where you actually have to write an equation. So write an equation for and graph a parabola with focus 2,1 and vertex -5,1. Even if it doesn't tell you to graph it, the clue to being able to get the equation is still to do some sort of graph, maybe just a sketch, not an accurate graph. And that will really help you come up with it. So the shorthand way that we might give you this question is we might just write this. Can you see what that means? F for focus, V for vertex. Now, how we actually look at your equation, the things we look for, have you written the equation in the form of a parabola? When you get to ellipses and hyperbolas, you'll really see what I mean there, because they look totally different, the equations. So basically, have you given me an equation where somewhere you've got x minus h, somewhere else you've got y minus k. On a parabola, they're going to be on opposite sides of the equal sign. So I'm going to look for that, and I'm going to look for you have squared one side or the other. That will mean it's a parabola if only one side is squared. When we get to an ellipse, both of those things, or a hyperbola, everything is like this squared. So just have you given me a parabola where one of the variables is squared, not both, and have you put in a coefficient somewhere, like either a 1 over 4c, or maybe you put in a 4c, yeah? And I'm then going to check that you have squared the correct side, that you put that on the right side, and I'm going to check that you put in the 4c or the 1 over the 4c on the right side as well, okay? So the very first thing you can do on this one, it's so simple. The vertex is your HK point. So I know I'm going to have x minus -5, and I know I'm going to have y minus 1, okay? But I have to work out which side is squared, and I've got to work out, so I've got to work out which side is squared, and I've got to work out my coefficient and put it on the right side in the right form. So just sketch what you've been given. Now I'm going to go straight to graph paper on this one, but you could sketch it first. -5, 1, label that as your vertex, and then your focus is at 2, 1. That immediately tells me so many things. From that, you can tell whether it's which way it opens, which will tell me which side is squared. From that, I can also tell whether my coefficient is positive or negative. And there's one other thing I can tell. So remember that a parabola is like a cup, and the focus is inside the cup. So that's inside the cup. This is literally going to have to open like that. Now, I don't know the width or anything like that yet, but I know that it opens to the right. And that tells me two things. It tells me it's not x that's being squared. It tells me that y is squared, and it tells me that my coefficient must be positive. Okay, so for now, I can put the squared on the y side because I knew it opened to the right. And when I write the coefficient, wherever I write it, I can write it as a positive. There's one other piece of information that gives us. That's horrible. I don't like that at the moment. I'm just going to move it out of the way. It also gives us, once we've graphed it, we can very clearly see the distance between those 2 points is 1, 2, 3, 4, 5, 6, 7. It's 7. You could do that algebraically. Look at the difference between this point and this point. Your x has changed. And the difference between that, doesn't matter which way you go, the distance is 7. Now, what do we call that length? That is your focal length. That's just 1c equals 7. When I get to my coefficients, I'm either going to write 1 over 4c, or I'm going to write 4c. It depends where I want to put it. But if c equals 7, then I know that 4c equals 4 times 7, 28. And I know it's positive, and I just like the simple form, so I'm going to put it on that side. Okay, that is my answer. You could, if you wanted to, another correct answer would be to put the coefficient in the form of 1 divided by 4c on the squared side. Either of those answers is perfectly good, and I will always accept either. Some teachers only want this one. The textbook only wants this one. I'll take either form, okay? So we have to graph this. Now we know the focal width, the lattice rectum, otherwise known as the lattice rectum, is that 28. That's the width at the focus. So there's the focus. The whole way across must be 28. So to do that, I'd go up 14 and down 14. And you know what? I can't fit that on my graph paper. I can't. It'd be up here somewhere from the focus. I'd go up 14 from the focus. I'd go down 14. This is a great big wide parabola. You don't go through the focus, but you do go through the vertex. And I'd have to graph the directrix, and that directrix would be 14 backwards over here, all the way through my work. I'm not even going to draw it, okay? I should if I was graphing properly, which the question said we were supposed to do. Now, you're going to try one of these on your own. It's not going to ask you to graph it, but if you graph it, it's really going to help, okay? I'm going to give you 3 minutes to see how you can do on that your own, okay? Hint, graph what you've been given and see if you can write your equation. This one is more difficult than the one I just did, but see what you can come up with. Okay, so for this one, it's harder. We've been given a focus. I'm not even indicating where that is, and we've been told it opens up. So if it opens up, the vertex is going to be underneath the focus. So, oh, I know it's going to have the same x value. So I know my vertex is definitely going to be at -1 and a number that's less than 7. I also know that it's going to be positive x squared. So in my equation, I'm going to write, let's move some of this stuff out of the way. Yeah. So in my equation, I'm going to have, ooh, no, I don't want to do that. It's a parabola. I'm going to have x minus -1, x plus 1, and that's going to be the side that's squared. Okay. And I don't know what to put with y, and I don't know my coefficient. And I kind of prefer the coefficient on that side. So I'm going to put 4c on this side. So what I still need to know is I need to know my k, and I need to know my 4c. I do know that that 4c is going to be positive, not negative. So you've already got a lot of points there for writing an equation just from that thinking there. Now let's see what else we've been given. We've got the 0.37 as well. So this maybe is going to be good to graph accurately now, because that might help me a lot if I graph this accurately. 1, 2, 3, 7. Right. That's the focus, that's the point. So now there's various parabolas. All I know is it opens up and goes through that point. Yeah? Gosh knows what it's going to be like. It's going to be something like that. But that has given me a lot of information. That literally has told me how wide my parabola is. The width of the parabola is called the Lattice Rectum, and that gives me 4c. So this itself is a distance of 1, 2, 3, 4. And I know that 4 equals half of the width. It's going to be 4 out the other side as well. Okay, so it's going to be 8 wide. It's going to be the width, the focal width. So 8 is going to be my value for 4c. Okay, I can put that in on the unsquared side. But I still have to find that k, so I have to find the vertex. If 4c equals 8, then 1c, the focal length, 4c is the focal width, 1c is the focal length, must be divided by 4, that must be 2. C equals 2. And that is the distance, the focal length is the distance from the vertex to the focus. Yeah, it's the distance between them. So I've got to go from my focus, because it opened up, my vertex must be down to beneath it. It must be there. If I'm going down 2 from this point, that 7 will turn into a 5. Or you can read it off your graph. Cross 1, up, 1, 2, 3, 4, 5. Yeah? So that's my C. I'm done. Right, you're ready for your exit ticket now. That one was more difficult. If you have any questions, stay on. But there's an exit ticket. And on the exit ticket, you're going to have to graph something. Hopefully you'll be able to, if you'd maybe do it on your phone, it'd be easier because then you'll be able to submit your photograph of your work. Okay. I don't know, maybe it's harder typing in the answers on your phone. If you can't actually submit the photo in time, then just add it as a comment to your submission. You're going to have to do something a bit, well, not quite as difficult as that one. You're going to have to do a question a bit like this, and you're going to have to graph something. So off you go and do your exit ticket now. You've been given 15 minutes to get it. Hopefully you'll be able to do it in less than about, I don't know, 5 to 10 minutes. Okay, off you go, guys. Have a lovely weekend.